Good morning. This is Teacher Annabelle and welcome to Physics class. Look at the pictures on your screen. Which moves faster? A horse near the outside rail or the near inside rail? While a hamster rotates its cage about an axis, does the hamster rotates or does it revolves about the same axis? These questions indicates the flavor of our new topic. But before we begin, I would like you to prepare the following things with you. First, your physics book, a pen, and a copybook. Today, we are going to talk about circular motion. I would like you to open your books on page 170. Our main objectives for today is to first compare rotation and revolution, identify and describe the different types of speed in a circular motion, and demonstrate understanding about the relationships among tangential speed, rotational speed, and radial distance. There are two types of circular motion. We have rotation and revolution. Ferris wheel turn around an axis. An axis is the straight line around which rotation takes place. When an object turns about an internal axis, that is, an axis located on the body of the object, the motion is called rotation, or what we call spin. When an object turns about an external axis, the motion is called revolution. Looking at the picture below, remember that the Ferris wheels rotates while the riders revolve around or about its axis. If you can still remember your social studies class or science class before, you would remember that Earth undergoes both type of motion. Remember that the Earth revolves around the Sun once every 365 and quarter days, while it also rotates around an axis passing through its geographical poles once every 24 hours. Before we proceed with the next slide, remember the word tangential speed. And remember that tangential speed depends on rotational speed and the distance from the axis of rotation. In circular motion, we have different types of speed. We have linear speed, tangential speed, and rotational speed. First, linear speed. Linear speed is the distance traveled per unit of time. The linear speed is greater on the outer edge of a rotating object than it is closer to the axis. So, when you are farther from the axis, therefore, you have greater linear speed. However, if you are near or closer to the axis, you have lesser linear speed. The speed of something moving along a circular path is also called tangential speed, because the direction of motion is always tangent to the circle. Rotational speed, or also known as angular speed. It is the number of rotations per unit of time. Remember that all parts of rotating object have the same rotational speed, even if you are closer or farther from the axis. It is common to express rotational speed in revolutions per minute or RPM. All parts of the turntable rotates at the same rotational speed. A point farther away from the center travels a longer path in the same time and therefore has a greater tangential speed. Look at the bugs on the picture. A ladybug sitting twice as far from the center moves twice as fast. Tangential speed and rotational speed are related. When you ride a giant rotating platform in an amusement park, the faster it turns, the faster your tangential speed is. Remember that tangential speed is directly proportional to the rotational speed and the radial distance from the axis of rotation. In mathematical equation, tangential speed is directly proportional to the product of radial distance and rotational speed. You move faster if the rate of rotation increases. You also move faster if you are farther from the axis. At the axis of rotating platform, you have no tangential speed, but you do have a rotational speed. That's because you rotate in only one place. As you move away from the center, your tangential speed increases while your rotational speed stays the same. Look at this example. At an amusement park, you and a friend sit on a large rotating disc. You sit at the edge and have a rotational speed of 4 revolutions per minute and a linear speed of 6 meters per second. Your friend sits halfway to the center. What is her rotational speed and her linear speed? That's right. Her rotational speed would be also 4 revolutions per minute. That's because all parts of the rotating disk rotate about their axis in the same amount of time. Her linear speed is 3 meters per second. It is lesser compared to your linear speed. That's because linear speed is greater on the outer edge of a rotating object than it is closer to the axis. It says that a tapered cup rolls in a curve because the wide part of the cup rolls faster than the narrow part. This example is being used in freight trains. So, why does the moving freight trains stays on track? That's because their rims are slightly tapered. The wider part of the rim travels a greater distance per revolution. Okay, let's see if you understand our lesson for this week. Let us take this question. Whereas a rotation takes place about an axis that is internal, a revolution takes place about an axis that is A. External, B. At the center of gravity, C. At the center of mass, or letter D. Either internal or external. Excellent! The answer is letter A. That is external. When you roll a tapered cup across the table, the path of the cup curves because the wider end rolls A. Slower, B. At the same speed as the narrow part, C. Faster, or letter D. In an unexplained way. That's right. The answer is letter C. The wider end rolls faster. Think about this. When you roll a cylinder across a surface, it follows a straight line path. A tapered cup rolled on the same surface follows a circular path. But why? Excellent. That's because the outer diameter has a greater linear speed. Well done, everyone. Thank you for listening. And don't forget to do your test written in your weekly plan.